Coming up on This Week in Radio Tech, our guest is Hal Kneller. Hal has been around the world, and he's going to be talking about single-frequency networks. It's a big thing outside the U.S. We'll try to understand better how they work and what's involved in making them on This Week in Radio Tech. This Week in Radio Tech is brought to you by Broadcast Supply Worldwide with a great selection, discount prices, and same-day overnight shipping at bswusa.com. By the new Ruby console from Lavo with AutoMix Smart Mixing. See Lavo in your future at lavo.com/TWiRT. And by Direct Current Broadcast e-newsletter. Get Direct Current in your inbox every Thursday with technical pointers putting you and your facility at an advantage. Hey, welcome into This Week in Radio Tech. It's Kirk Harnack. This is the show where we talk about everything from the microphone to the light bulb at the top of the tower and a lot of stuff in between. Although for this show, it's going to be stuff at the tower site for the most part. Our guest, well, we'll get to our guest in just a second. I'll keep that a secret for a second. Our guest is amazing. He's been around the world and done a ton of work on the topic we're going to talk about. And I'll let him talk about the topics. That's coming right up. Also with us is my usual co-host, my buddy, my friend, my colleague, my pal. It's Chris Tobin. Hey, Chris, welcome in.
Hello, Kirk. How are things?
Very well, very well. You are getting ready for a broadcast yourself there.
Yes, our monthly broadcast. It started off again this year in February, and we'll be doing it this evening at 8 o'clock. So I thought I'd use the cameras, use the backdrop. Why not have some fun? The audience in the back will not be for TWiRT. It will be for another program later this evening.
Well, I guess we have a certain out time so the audience can come on in, or do we have some buffer time in there?
No, we have some buffer time, but that's okay. We can make it work.
Okay.
I've done crazier stuff.
Cool. Chris, just for those of you who may not know, Chris is the chief engineer at WBGO, wonderful jazz station in Newark, New Jersey, right?
Yes, it's a public affairs show this evening, but right now it's all music. So if you go to wbgo.org, you'll hear the best.
You'll also note that if there's a tall building in Manhattan that needs some extra super complicated work done, then you'll find Chris doing it. Isn't that right?
Yes, that's true. I have been doing some work on top of some of the skyscrapers in New York City. What was the most recent one we did? I think it was Citicorp. Yeah, the building with the slant. For those who don't know what the Citicorp building is, it's the building with the slant in the New York City skyline. That's
one that you don't want to try to stand up on that slanted roof because you'll slip right off.
Well, there is a small parapet. There's about 4 feet of rooftop and it's protected by a rail. But yes, you should be wearing a fall protection harness. It's a good idea.
Yeah, it just looks scary as heck to me. All right, well, cool. Hey, let's bring in our guest. I've been wanting to bring our guest on for quite a while now, and we just, for whatever reason, never got around to getting connected and setting a date. So we set a date, and today's the day. So he's here. It's Hal Kneller. Hal from Florida. Welcome in, buddy. How are you?
I'm great. Thanks for inviting me.
I'm delighted to have you on. Hal, I've known you for some years. I guess I've known you as working for a couple different broadcast equipment manufacturers, both Nautel and Harris. But that's certainly not the extent of your career. Why don't you, before we take our first commercial break, why don't you just tell us a little bit about Hal Kneller, and then we'll preview the interesting topic we have for the show.
Well, let's see. I was born on Long Island. Or maybe you don't want to go back that far. So I majored in mass communications at Emerson College and started in broadcasting while I was in high school, mostly on the technical side. Sold some broadcast equipment over the years, as you mentioned, with Harris and Nautel. I also did international sales for Ubiquity. But on the same time that I was doing all of that, I was also a station owner. For the last 30 years up until about 2 years ago. So that's where we are now. I'm doing some contract work part-time, semi-retired, a little more personal travel as opposed to business travel, and having a great time keeping my fingers in it still.
So yeah, you've been a station owner, and that's pretty interesting. We might hear a little bit about that. Actually, you are still a station owner with me. We're partners.
That's correct. That's correct. Although I don't think technically we own it yet. I think we're waiting for FCC transfer any day now.
That's true. That's true. Well, we may speak a little bit about that later in the show. It's just kind of interesting. You and I own a station. We didn't really know we owned a station together, and by own, I don't know what you own, Hal, but I own like this much of it, just like I don't know, 1% or 2%.
That's exactly right. We're equal partners.
Equal partners, yeah, equal partners with us and 48 other people, something like that.
Yes, of our closest friends in the industry.
It's going to be interesting. Hey, Hal's subject is going to be about single frequency networks, and that is something that we don't have much of in the U.S., but in other parts of the world they have them, and it may be a really good way to not only extend the reach and the convenience, the reach of a station, the convenience of listeners listening to it, and you can do some geo-targeting, and that's pretty interesting too. And it doesn't apply just to FM analog, which is how I was introduced to single frequency networks, but we're going to talk about how SFNs apply also to HD radio and to the new television standard, ATSC 3.0. So that's going to be coming up. So I hope you'll stick around for that. We're going to talk about single frequency networks. Our show this week in Radio Tech is brought to you in part by my friends and my employer, thankfully, the folks at the Telos Alliance. Let's hear a message from them, and we'll start our show with Hal Kneller as we continue. Go ahead.
You need an audio processor. And that's when my ears perked up. Oh, what? Tell me about this. And it goes, I don't know, it's a box that splits the audio into 3 bands and puts them all back together. It basically makes a radio station sound louder than it really is. At least that's what my friend says. That sounds exactly like what I need. It needs more sparkle. It needs more of this. I need more thump. There's a control that if you turn up thump, okay, it's programmed to turn this, tune that, tune this by that much, tune that by that much, tune this over here by this much, and diddle these other controls that normally would be corny only access controls to give you more thump. But along the way, Frank goes, Corny, this dynamic EQ, it's amazing. I think this may have some application for audio processing. Play with it. Now, the point of a bass clipper is to try to keep the bass from creating high-frequency intermod distortion on the main clipper. Each of the bands can hone in on their individual spectrum, the way they should. You can build up nice RMS loudness without having to worry about also loading onto them the EQ balance. Basically, what I hear and what other people hear is that the audio takes on, it's like taking a 2D picture and making it 3D. On the surface, that sounds like weird, but the proof is in what you hear on the air.
You got to check out this link, and I'll put it in the show notes on the show here. Or you can go to telosalliance.com, and somewhere there you'll find it, or go to the YouTube channel. Just go to youtube.com and look for Telos Alliance and see the whole channel there, and you can find the interview right there. It's kind of long. It's an hour and a half, but just start playing it and do something else. Perk your ears up when you find something interesting, which might be the whole 90 minutes. All right, it's This Week in Radio Tech. Chris Tobin is along here, and so is Hal Kneller. So Hal, single frequency networks. Your interest in this started on a vacation, or what was how did this begin?
Yeah, exactly. A few years ago, my wife and I went to France. We landed in Paris, and we wanted to go out to Normandy to see the famous beaches from World War II. The D-Day landing areas. And I had heard about this extensive SFN, single frequency network system they had along the highway. So I turned it on my car radio and listened to the same station for probably 300 kilometers through mountains. And certainly it wasn't from a single transmitter that I was hearing the signal that whole distance, because it would have been totally lost in the terrain. And it was rather fascinating to listen to. I got a little more information about it from some people that knew about it afterwards. I did perceive some multipath in places, but what was really interesting was if you looked at the terrain you were in with a lot of mountains, I wasn't sure whether I was hearing multipath caused by the terrain or whether I was hearing mesh transition zones between the different transmitters that were on the same frequency and synchronized. It didn't sound bad. I mean, The multipath areas were not highly annoying. Being a broadcast person, I'm more aware of them perhaps than even the average person. So that kind of started my interest in SFN. We don't have a lot of it in the United States, but I should say that outside of broadcasting, we actually have a lot of single frequency networks. When you think about the old days of paging services and technologies that were using SFNs, even some trunking systems were using them back in the day. So it's not a new technology, but it might be fairly new to broadcasting, and not without its initial problems, because over the years, a lot of people had tried what we call boosters or single frequency network things with a lot of interference, and some were turned off. It might solve a problem in one place where you were having a signal issue, but you might then create a problem in another place where you used to have a good signal, but now you got a lot of interference. So, as I said, some were turned off. With good terrain shielding, some of them were successful. But now the technology has morphed to the point where we can actually have zero terrain shielding and mitigate the interference, which I think from a technical standpoint has really put the technology in a place where we can implement it in a lot of places where we would not really want to do that in years past.
You know, you mentioned paging networks of old, back in the 70s, 80s, where you'd have a wide area of coverage, and then no matter where you went, your pager would work. And it was a fixed-tuned pager, probably, so it had to be on the same frequency. But those networks, they didn't have to be synchronized in any way, did they? They could operate, each transmitter had its own independent oscillator, and your pager would just kind of pick up the one it was nearest to, right?
You're absolutely right, and you used the capture effect of the receivers. So what they typically did was they would have a network. They were all on the same frequency, so therefore it was a single frequency network, but they would stagger the transmitters. So they would turn on transmitters simultaneously to emit the paging signal. Then those would shut down and another set would come on. And they try to do this such that the geographical separation between those transmitters was such that they minimize the interference.
Ah, okay. All right. I didn't know they had that kind of a control going on. So that's one example of a single frequency network. There's also countries where it's not really a single frequency network, but for example, in Australia, some TV station will be channel 9 in every market. They get channel 9. So the branding, that's more of a branding thing. The branding stays the same everywhere across the country. But that's not what we're talking about either.
We're talking about a synchronized network.
Yeah,
exactly.
Yeah. So now my only exposure to this has been in the U.S. has been with an on-channel booster, where you'd have maybe some area of your coverage for your FM signal that was blocked by terrain or something, and you wanted to fill in the area behind the terrain. And so there were a couple or three different techniques for retransmitting your FM signal into the blocked area so you could have coverage there. And you wanted, I guess, here, tell you, explain to me and our audience. The idea of synchronizing has to do with minimizing the interference area. Why do we get an interference area if they're not synchronized, and what does synchronization do to minimize that?
Okay, so if we have 2 FM stations or more than 2 FM stations, when you have very short space situations, I know around New York area, Long Island, New Jersey, Lower Connecticut, there are some stations that are on co-channel with each other, and when propagation conditions are right, you get a tremendous amount of noise. Sometimes the more distant station will overtake the more local station. It becomes unlistenable. So that's on the same frequency, but not synchronized, and really creates a mess. What we can do is totally synchronize the stations, starting at the oscillator. So we use a GPS, a 10 megahertz reference from the GPS, locks the exciters to the same exact frequency. Then we need to maintain exact modulation characteristics for the entire baseband. So the mono portion of the signal, the stereo portion of the signal, RBDS, everything all gets tied together and synchronized. But that's still not good enough. Suppose we have 2 signals, one the main station and one a booster, and maybe they're 30 miles apart, 40 miles apart, and I'm somewhere between them. the RF from one of those sources will get to me before the other one. Similarly, if I'm in the canyons of a big city and I'm getting a reflection off of a big building across from me, and I'm getting signal from the main transmitter, New York City comes to mind with the Empire State Building and lots of tall buildings around. The signals are just echoing all over the place. That's multipath. Multipath is when you have the signals arriving at the station, at the receiver, at a slightly different time. So our goal in synchronizing is to not only do all of the stuff that we talked about a minute ago about frequency synchronization and having all the modulation components to be aligned, but we also have to calculate the area in which we are trying to protect so that we minimize the interference in that particular area by having the timing set so that the signals arrive the same. And it's a complex formula that involves the ratio of the signal from each of those transmitter sites. And by the way, in a multi-node system, it could be 2, 3, 4 signals coming in at a given point. And the timing between all of those to make them arrive to the receiver at seemingly the same time. So that means that we have to offset the timing of one or more of those transmitters to come in at the time we want it to come in and minimize that. And it's pretty complicated. It's not something that the typical RF consulting engineer who's great at doing FCC applications and answering questions and working with the allocation system, many of them are not familiar with all of the nuances of a single frequency network. So there are some specialists out there who deal with it, and that's kind of what you need to do if you want to optimize the network.
So it sounds like, I guess primarily we want to try to use capture ratio, that is the difference in signal level and then FM receivers' natural propensity to pick up and lock onto the strongest one. We'd like to use that first because that's the obvious one that we get as a benefit of an FM receiver. But in places, the capture ratio is what, typically 1.5, 2 dB on a receiver? Is that what it about is?
Some are 3 or 4. It depends on the receiver. You know, a $10 radio at Walmart will not have as good a capture as, say, your car receiver, which are typically some of the best receivers on the market. Okay,
so you may if you have a cheaper receiver, if you got 2 signals, even if they're within 3 or 4 dB of each other, that's kind of far, but it's kind of close. Then you got to depend on something else, and that is the signals arriving together with the same modulation in the respective exciters, modulating the signal the same way. And it was just, you really want to try to synchronize it. Now, you can't synchronize it everywhere. I guess you want to try to synchronize it in the area where capture ratio doesn't work. Is that right?
Yes, and we do this by several different methods. For example, the systems that Geo Broadcast Solutions, whom I happen to consult with, they use very tight directional antenna patterns. So we aim the signal where exactly we're trying to put it and minimize the signal where we're not trying to put it. And that could be, for one customer, was a stretch of highway. They had a very, very poor signal with interference between 2 cities that were heavily commuted. So we didn't want to lose that highway. So one of the nodes simply lit up a couple of mile stretch or 5 mile stretch of interstate highway. Very few people lived in the area of that signal, but thousands and thousands of cars traversed it. So they didn't want to have people dialing out in that area. There are other nodes obviously concentrated in populated areas. So we aim where we want to be, and we minimize the splash in other areas where we don't want to be. The second part of it is, the closer the signal ratios are, you were mentioning 2 dB, 3 dB, those are pretty darn close. And the best of FM receivers are still going to have issues with that kind of ratio. So it is very critical when we're in an area where the signal is that close that our timing has to be adjusted to bring those very close into synchronization. As we move away from one of the signals and toward the other, now the ratio increases, and we have a lot more tolerance on timing. So we can have a slip in timing as long as we have a large difference in RF signal between the two signals. So the tighter the signals in terms of ratio, the more critical the timing.
So I'm trying to get a bead here, and by the way, I need to ask Chris in just a minute about his experience with SFNs. So Hal, I'm trying to visualize this in my head. We know that at 100 megahertz, an FM wavelength is what, roughly 10 feet or so, and so does that? I mean, it'd be impossible to synchronize them in such a way that I mean, that every 10 feet. I mean, if you move 10 feet, it doesn't totally disappear or mess up. So I guess what I'm trying to ask is, what in an area where there's the capture ratio is not helping us, where the signals are close to each other, the radio needs to receive 2 or more signals that are adding constructively and not adding destructively. But maybe I'm misunderstanding this, because FM radios all have a limiter in them in the just before the discriminator that makes that turns it all into basically like a Class C amplifier. Maybe I need to ask you to help me ask the question here. What is it that we're trying to actually synchronize? The modulation of the FM signal up and down, the actual FM waves at 100 megahertz themselves up and down, or something else?
All of the above. The frequency from the GPS, the 10 megahertz reference into the exciter, that has to be referenced, and then we have to have commonality of the entire modulation component from 50 hertz on up through the 38 kilohertz through the passband to the RBDS. So any failure, including, by the way, the percentage of modulation, we found that if you're off more than about 0.3 of a dB on the modulation, that creates a lot of noise in the network.
So, hey, I have a question that has to do with the way one company distributed this, but let's bring Chris in. Chris, in your area, do you have any experience with SFNs?
I haven't done any in a long time. Back when I was in Connecticut, yeah, we had one. No, we had 2 doing FMs that were doing co-channel SFN, what do you want to call it. The hardest part is synchronizing the oscillator, everything in the chain. And I think Harris had a product, it still does, Syncast or Synchrocast, something to that effect. And you basically lock the oscillators of the transmitters, you lock everything you can, and you time it and base it on GPS, and you go for the best. There is a zone of interference, an area interference of the overlap, and then the trick is, as Ed pointed out, you have to position it. I went to Rosenberry, the I-95 corridor, north of Norwalk and Darien and stuff, and they had a synchronized signal in, I think it was Darien, or was it Rowayton, down by I-95, and their zone of interference happened to fall in an area between Norwalk and Wilton. That was,
so we're getting some cutout on. Sorry, Chris, your signal's popping in and out there, both audio and video together. So, Hal, let me ask you about this technology. Chris and you have both mentioned systems where the transmitters, the exciters, are synchronized with GPS. Okay, what about that system? I thought TFT made it, where there was a master exciter, if you will, and that they reduced that to an intermediate frequency, an IF, and then you would ship that IF signal around, which would be modulated exactly the same way everywhere it was picked up and received, and then you multiplied that IF back up to the carrier frequency and broadcast that. And then it seems like then you simplify things a lot that way, but you still had timing. You could delay certain places. How can you, and that was my introduction to a single frequency network that would actually might be synchronized. Can you speak at all to that technology, Hal, and if it's worthwhile or if it's really passé?
I do remember that, but I don't ever remember it being in an SFN. I remember them in a product that was called the reciter. And I thought it was used with translators, where you would pick up the main station, the home station, and they would then beat it to an IF frequency, and then beat it to a whatever the resultant carrier was supposed to be on the output of the translator. So that was how I understood it, and I never knew it to do SFNs.
Oh, okay. Because if obviously if you're doing a translator on a different frequency, it really doesn't matter if they're synchronized. You want the audio to be kind of the same, but they don't have to be perfectly synchronized. Right. Your radio's not trying to pick them both. I understood the reciter to be for an on-channel booster, and that was a good way to get
that.
them. Okay,
that was a long time ago.
Yeah. But I remember it was it was all analog. It was all analog,
and so
it was kind of finicky, but if it worked, it should have worked pretty well because you were actually transmitting at booster sites or a booster site. You were transmitting exactly the same modulation and modulation index you came up with at the original site because it was there was nothing demodulated, decoded. It was the same RF, just at an intermediate frequency for easier distribution to other places.
In theory, that should work well. The problem with that is you have to assume that your booster sites can pick up the main station off air, which in a lot of the boosters that we have worked with, that is not a possibility.
Mm-hmm. I'll bet you somebody may comment on my misremembering of how it worked, but somehow they were shipping either the IF or some product of the IF. They were shipping that around. Well, I don't know. I better not speak to it. So, but anyway, apparently that technology is passé. We can do either a better job or an adequate job using things that aren't so finicky, and that would be the GPS.
It's gotten a lot better
system. Yeah.
Let me just hit one thing on FCC rules, because we talked about this French system, and you had mentioned about extending coverage, and I just want to be clear about how in the United States the FCC rules are. We put boosters in under Part 74, which is the same part translators go in. The thing is, you are not allowed to extend your contour. You have to have your boosters, whatever there is, 1 millivolt or 54 dBu, depending upon your class of your station, or 57 if it's a B1. So they cannot push past your main station's contour based on the FCC method of determining the contour. Can't use Longley Rice or whatever to try to say, well, my contour is really out here. The other thing is, if you're a grandfathered station, the boosters have to keep their contour within what would be the regular signal if that station was a regular full class station as opposed to over the top of the class. So you have some grandfathered Bs, some grandfathered Cs. A booster would have to be its coverage only to what that station would be ungrandfathered. So there are a few quirks in the rules. We use them for terrain problems. There's several that we have done which are rim shots. For example, there's a station in Boston that we did. Its transmitter's about 20 miles north of town. The signal in town was not competitive with the stations on the top of the Prudential building and other buildings, Hancock downtown. But by doing a single frequency network with a total of 5 nodes, one of them was on top of the Hancock building with a measly 24 watts, and it lit up downtown very nicely.
So we're going to go to break here pretty soon, but tell me, is there a legal framework, a way in the U.S. that an owner could conceivably come up with a single frequency network to cover a decently large geographical area that the owner was interested in?
The answer to that would be, as long as it's inside the contour. So if he's got a massive high class C antenna with a huge coverage area, he could, but it's perhaps cut off by terrain, he could put in a bunch of boosters. There's no FCC limit on how many boosters you can put in. He can go to town. It's all about how much money you want to spend. But no, he could not put in a single frequency network that exceeds the contour, except for one exception. I ran into it in Hawaii. I didn't even know it was an exception until Don Muscle pointed it out to me. If you have a white area, which has no service whatsoever from a broadcast station, AM, FM, or television, then you can exceed the contour with a waiver.
It's interesting you mentioned Don Muscle. I talked to him on the phone just a day or two ago. And he was consulting in Kauai at our station.
Right. So he does a lot of work out there, but I was working on a thing for Hawaii Public Radio. We took a look at a possible scenario for them, and I looked at an application he had in, and it was outside the contour. And I said, Don, how do you do that? And he says, oh, look at rule such and such, 73 such or 74 such and such about white areas. Like, there it was.
So is it possible or feasible in the U.S. and in our regulatory scheme that a person might own several stations on the same frequency that are properly spaced, like let's say 94.3 with that? I think it's typically a Class A frequency. That if you own several, that could you make a chain and an SFN out of that if you legally owned these stations?
Oh yes, one of the first that I remember hearing about was Al Kirshner did it for a company called Big City Radio. They had 103.9, I think it was. I don't swear to high frequency, but they had one in Eastern Long Island. They had one in Westchester and one in New Jersey, and they synced them all up and did a pretty good job with it.
Chris might be familiar with that one. Chris, you remember that?
Oh yeah, remember it well. There was, yeah, big city. They had them on Long Island, Westchester, and down in New Jersey, South Jersey, I think it was. And was it 107.1? I think it was at one time. I believe that's correct. 107.1. Yeah.
It worked pretty well.
Yeah.
One of the problems of that era is the equipment was not as stable as it is today. The other problem that you had in single frequency networks was you had some kind of a connection, a T1 line typically, over the last years. Sometimes the phone company would make changes in the network, which would change the latency in that system. Change the latency, and automatically you've messed up your sync.
Oh, yeah.
Yeah, wow. If you took your
now
timing,
the system takes into that.
Hey, we've got more to talk about, including single frequency networks, and in France, where you first experienced this, Hal. After the break, I want to hear about, what's the effect for a listener? What do you get to do as a listener when you are listening to an SFN and maybe traveling some distance? How does that work out versus the RDS system that they use in Europe? That's they use the alternate frequency where the radio just automatically tunes to other stations transmitting the same audio using the AF tag. But we'll get to that in just a minute. Our show, This Week in Radio Tech, it's episode 383, and Hal Kneller is our guest, along with Chris Tobin, getting ready for a live broadcast there in Jersey. I'm Kirk Harnack, and we got to hear from our friends at Broadcast Supply Worldwide. Let's roll it.
Hello, I'm Frank Furter. As you know, week after week since 1973, it's been BSW's honor selling products to broadcasters worldwide for the best possible prices and speedy, zippy delivery. How do we do it? Let's show you the magic.
Welcome to the fictitious BSW Sale Factory. This is where all the products that are put on sale are staged and, once ordered, are placed on high-speed conveyors.
The Henry Engineering 6-Mix 6-Channel Broadcast Console. 10 inputs and 6 channels for $5.95. Over $550 off. Now, back to the factory.
No other sale factory in the world uses such amazing technology. Here, a BSW-trained computer technician at work. Looks like he's adding that Wi-Fi that we've been hearing so much about. Great job, Billy. See? You turn the knobs and then BSW exclusive deals pop out. It's that easy. See, Billy?
Interested in podcasting or internet radio? BSW's Going Pro Kit Dual with PR40 microphones will have you broadcasting in style on the WWWs in no time. Only $12.69. Now, back to the factory.
At the BSW Sale Factory, workers are on double speed to route your emails and direct your calls to our happy sales representatives.
Introducing the BSW Orban Demo Program. Want to hear what the best processing in the business sounds like before you change lives with its amazing sound? Call BSW today and ask for a demo on Orban processing. Now back to the BSW Sale Factory.
Operating a sale factory requires exact timing and product planning to make sure the products you want to buy are priced low and ready for immediate shipment. On behalf of the entire BSW staff, thank you for watching, and don't forget to buy stuff.
Remember, you can You can order as late as 7 p.m. from Eastern Time, 7 p.m. Eastern Time from bswusa.com. And if you want it shipped out tonight, you can do that. They'll put it on a plane in Columbus, Ohio, and have it to you the next day if that's what you want. And, you know, me, I usually forget to order stuff. So there you go. Appreciate the BSW broadcast supply worldwide at bswusa.com. Hey, it's Kirk Harnack, episode 383 of This Week in Radio Tech. Chris Tobin and I are talking with Hal Kneller, who has a international experience. And Hal, you began the show talking about your experience in France. And I experienced this radio network as well in France. I was being driven. I did drive. Come to think of it, I did drive in France. They drive on the correct side of the road, and so I could do that. And yeah, listen to the same station for hundreds of kilometers because they only transmit along the highway. Tell me about the user experience for that.
I was pretty amazed with it. The quality of the sound, the mesh zones were quite well controlled. As I mentioned earlier, it was mountainous over part of the route, so you didn't really know whether you were hearing some multipath that was generated naturally by the terrain or whether it was transitions, because I didn't know exactly where the transmitters were, and that's pretty cool. I mean, being in the business, I'm pretty conscious of, you know, deleterious effects on reception, and it was pretty darn good.
Yeah.
Everything, including the RBDS, stayed right just the way it should, and we had great reception the entire trip through flat terrain, through mountains, all the way until we got to the shores of Normandy. You know,
and I was driving south out of Paris from Orly Airport down south to Orléans, and on a second trip I was way down in the south of France, and I sure did notice that one place where they do have these transmitter sites is at the toll booths, because that's a natural place for the government to locate some equipment. They've already got equipment there. They've got a property there. It's not much more trouble to put a pole, a monopole, or a tower there with what I remember seeing were Yagi style antennas pointed up and down the highway. You know, about 3 or 4 Yagi style antennas on a pole in each direction of
typically vertically polarized, right? Vertically polarized.
Yes, exactly. Yeah, well, like the antennas would have been until recently.
Right, exactly.
Yeah.
It worked well.
Wow.
What can I say? They have it on hundreds and hundreds of miles of roads. The other thing about it is the frequency spectrum efficiency of an SFN. Think about how many frequencies that you would tie up and make unavailable for other services if you had to do a normal allocation using different frequencies. You'd have to space them. You'd have to probably use 5, 6, 7 frequencies to do what they're doing with one. And so SFN does improve frequency spectrum efficiency. In fact, we've even suggested to the FCC they consider allowing it on translators for AM stations, because some AM broadcasters have picked up 2 or 3 translators to cover their area. Well, those are a couple of frequencies that competitors couldn't use or other services couldn't use. So the idea is that they could perhaps do a network.
So help me understand a bit better the equipment that that Gates Air supplies that helps you create a single frequency network, and what. So tell me what are the parts and pieces needed from the studio out to several transmitter sites to make this happen?
So basically, we start at a reference point. The reference point could either be at the studio or it could be at the main transmitter site. We need IP connectivity today between all of these different sites. At the main studio or transmitter site, depending upon what your reference point is, we would use a Gates Air IP Link 200. We would use a GPS system blocking the audio, because every packet is time-stamped. And if it's at the transmitter site, the 10 megahertz reference out of that GPS is going right to the master oscillator in the transmitter to lock it on, so we have precise frequency lock there. We would also have the audio processor at that particular location would be the main audio processor, but it could be at the studio and brought up by AES audio. It's not really critical at that point which end at the studio or transmitter the processor is. We feed AES audio into this Gates Air IP Link 200. The IP Link 200 goes into the transmitter site exciter at the main site, and then goes out and feeds the IP network to 1 or 2 or 3 or 4 more nodes, however many you have. Could be 100 nodes, doesn't matter. That signal is either standard AES-3 from the 1992 standard, and we would have another stereo generator at the booster sites, or we could use AES-67, and we would convey basically a composite baseband signal out to the different sites and not use the stereo generators at each site. That would be advantageous in terms of better stability, identical modulation component, and of course cost. You don't need to have a stereo generator out at those other sites. So we like the AES-67 distribution path. The power of the boosters is normally not terribly high. The FCC allows you to use 20% of your class power. If your station is over height, the main signal is over height and therefore reduced power, it doesn't matter. A class B station can still, run 20% of its 50 kilowatts into a booster.
Okay. I'm starting to get the picture here. What?
But we don't usually run that much power because it creates interference.
Gotcha. Okay. So what's the procedure for time aligning this? Do you have to put people out in the field in certain places? How do you get things aligned the way you want them to be?
First, we start with the calculations. The proprietary programs that GBS uses actually are from a company in France, ATDI. They build a product for the cellular industry, which has been customized for us to do what we're doing with the synchronization. It's much more precise than most of the programs that you see used in this country. I'm not trashing on them. VSoft makes a great program for allocations, but it's not specifically designed to do SFN work. So this is. So we have that, and that will give us what I'll call the initial launch delays, we call them. That would be the initial timing settings for each node. And of course, we have to put some delay in the main transmitter site just to make sure we have enough fudge in the system to be able to, we don't want to run out of corrective time. We have to be able to have enough there. So many of our stations are running HD radio technology. So what the heck is another few hundred milliseconds of delay? They can't monitor off the air anyway in the control room because of the 8-second HD delay. So another few hundred milliseconds makes no difference. Those stations who don't have HD radio, they don't like it as well, but they get by it. So we use those initial launch delays, and then we use a good old-fashioned car radio, an automat navigator, and we have some other tools that we use. But mostly you go out and you listen with your ears. And the guys that we have doing it are pretty experienced. They know what they're hearing, and they know based on what they're hearing the tweaks that you have to put in for the timing. So we might move the timing a few microseconds one way or the other, adjust a couple of different nodes a couple of different ways. But as I say, they know from the mapping program what the interference areas are, and we attempt to mitigate them as best as possible. Sometimes you can move an interference area. Chris was mentioning around a highway, I-95 in Connecticut or something. We have the ability to make sure it doesn't go on the highway. We can shift it off, hopefully into a non-populated area, over the water, if it's an area where there's lakes or the ocean or something. So we have quite a bit of control to not only adjust the timing, but also to adjust the interference areas. Because interference will always exist. It's a question of what you can do with it and how much you can mitigate it.
That's a good point. And I was just thinking about it. Here where I live, we don't have much water, but of course on the coasts you do, and wherever there's inlets, and you can use that to your advantage because there's not many people filling out Nielsen diaries on the water. They probably have better things to do. So yeah, you can use water or mountainous areas where there's nobody lives up that holler or on that ridge. You can make that your interference area and hopefully steer your non-interference area toward an area of population, whatever town.
There's another interesting thing that they did was the hired NPR labs, who then went and got Dr. Ellen Sheffield and Towson University. Basically the same drill that Ubiquity went through, if you remember when they were analyzing the codecs. the PAC codec versus what became HDC. And then later, these folks did the codecs for radio reading services for the blind. So Geo hired them, and they put an auditorium test together, because nowhere in the FCC rules or in the ITU recommendations did they have specific information on what level of signal interference would be tolerated, and when would it cause people to tune out, what would be okay for mono, what would be okay for stereo, what would be okay for music, what would be okay for voice. So all of these things, hundreds and hundreds of audio samples were generated, and they did basically like an auditorium music test that a lot of stations do. And we got good data, so we know what the audience will typically respond to in terms of when they're ready to push the button or when they're ready to stay on. So all of our mapping is based upon a 90% keep-on score. If 90% of the people will stay, then we don't consider it an interference area. It drops to 89%, and it's shaded on our maps in magenta. Now, in reality, a lot of times when you actually take your car and you go out to that area, you'll either say, oh yeah, there's a really small amount of interference and it's right where the map says it's supposed to be, or they'll say, you know what, it's supposed to be here, but I don't even hear it. So that's kind of how it works.
So I'm a little
without
curious
the proper planning tools, it's hard to do.
Okay. So I'm a little bit curious about the interference area and how that relates to, let's say, heavy modulation, because we know that if your station suffers from some multipath interference in certain areas, if you are a station, if you're talk, if you play classical music or light jazz, that multipath distortion is easier to notice. But if you're playing metal music, it may be a little hard to tell the multipath from the music. But seriously, if you're processing really hard, you have a real high modulation index. If you're just really dense, then in terms of your audio, then you may not notice that multipath as much. Is that kind of the same general rule? Do you have a difference in perceived interference for different formats?
Absolutely. And also mono versus stereo, like a 10 dB difference. So if it's a talk station, then we recommend the boosters be run in mono. We've even run some boosters in mono on some stereo stations just because it reduced the interference areas and the customer wasn't that concerned that the boosters be in stereo. But normally we design the system to operate with a stereo main and a stereo booster. But we have to be more critical in terms of the design criteria. For example, if it were a jazz or a classical station versus a heavy metal station.
So Chris Tobin's going to have to go, and I know he's been listening with interest. And we don't have a whole lot of this stuff in the U.S. We had the example that you guys mentioned for the Northeast. Chris, what are your thoughts? I'd like to hear your thoughts on this, and if you have any questions for Hal, now's a great time to ask him.
Well, single frequency networks play a great role, but here in the States, things are so different than elsewhere, and you travel and come across it. It's hard to say when it's best applicable. But one question I do have, since you've been involved in, Hal's been involved in ATSC 3.0, I hope that's correct. Do you see television folks going in a single frequency network operation with ATSC 3, since that offers a lot of opportunity that the current HD doesn't?
You're right, Chris. It's hard to say how many are going to do it and how quickly. The concept is definitely there. In Europe, they've been doing it for some time. With digital, it's pretty easy to do a single frequency network. In fact, it's a lot easier to engineer an SFN in digital than it is in analog. Analog's very much more tricky. So
this is true.
ATSC 3 is going to offer several advantages in terms of setting up an SFN. And there may be reasons to even do a simulcast SFN in areas where they're trying to get robust mobile reception, smartphone type reception. South Korea has been doing this for at least 10 years. We're well behind the curve on that. I was surprised when I went to Korea and I saw how many people were watching all kinds of over-the-air stuff on there. Not streaming like we do here, but over-the-air stuff. And we can do that here now. So the SFN will do two things. It will create a more robust reception in the entire coverage area, depending upon how they lay out the SFN nodes and where they lay them out. The second thing that we'll be able to do, as we were touching on earlier, is that you might be able to take a market like Minneapolis, St. Paul, and set up a network where you, at certain times of the hour, you could break off and create separate content in Minneapolis versus St. Paul. Let's say we have a car dealer, and we got a car dealer spot in each city. Minneapolis people aren't necessarily going to get a lot of St. Paul people to come over to buy a car, and vice versa. So maybe you run a Minneapolis car dealer spot in Minneapolis, and you run a St. Paul spot in St. Paul, just as a concept. Big markets like LA, could you see Orange County being broken off from, say, LA County? In New York, maybe Nassau, Suffolk get broken off, and New Jersey has a separate node, with Lower Connecticut having another node. There's a lot of different concepts you can do here. And now that that's done in terms of the rulemaking that Geo Broadcast has pending before the FCC would allow us to do zone casting on FM, which is where we would be able to take an FM signal and break it up into 2 or 3 or 4, or however many zones the licensee might want to do, and put out different emergency alerts in the different areas depending upon where they're applicable. Very large coverage stations might have different weather forecasts in parts of their coverage area. And certainly from a commercial standpoint, many clients don't have need for the entire coverage area, so you could break it up and sell different commercials in different zones, getting people on the air who might not necessarily be able to afford to be on the air if they have to buy the full coverage.
That's okay. I understand that. Yeah. One more question. With ATSC 3.0, do you think that the layered modulation, or is it layered modulation multiplexing, will that help stations, TV stations, say your RF signal strength close into your tower is what you need for a good portable mobile operation? Well, I'll say portable mobile, and then say a secondary ring farther away is probably best suited for mobile rather than portable, and then have different programming for that. Do you think that is something that might be considered, say using New York City as an example, where you could have part of the layered multiplexing for the 5 boroughs, and then maybe another multiplexed channel for, say, Nassau County or Westchester County or Essex County in New Jersey?
Exactly. That's going to be up to the licensees. I don't know even how fast stations are going to even take on ATSC 3. Certainly they can't all take them on too quickly because there's no tuners out there. And unfortunately, the ATSC tuners that are in existence today in the television sets will not tune ATSC 3. So what they envision is 1 or 2 stations in a market may take on ATSC 3, and they'll be simulcasting on the other channels to allow the ATSC 2 people to be able to continue to receive signals and not lose them. And then over a number of years of transition, as the new tuners come in and people replace television sets, whatever, then ATSC 3 may become a reality all across the band. Now, whether they go into SFNs and split off programming to outer tiers or inner tiers, that's going to be up to them. You're right that you need a lot more signal for a mobile device than you do for I'm sorry, a lot more signal for a portable device than you do for a mobile device, like in a vehicle. The problem has always been that, with a secondary problem for the existing ATSC system now, that the Doppler effect doesn't work well, and in moving vehicles at higher speeds and portables never really got off the ground with this system. So that's one of the things ATSC 3 is going to address.
Yeah, my understanding is the modulation schemes in the ATSC 3 is much more robust and takes advantage of the bit error rate reconstruction more so than the current ATSC. So you're right. Yeah, absolutely right with that. At least my experience with using portables.
Europe, DVB-T, DVB-T2 was a newer system and took advantage of some evolving technologies that weren't here when we first invented ATSC. And it's been the case all along. As technology progresses, the first guy in does not necessarily get the best system.
True. Well, I have the fortunate opportunities to work up at World Trade Center recently, and to work alongside and talk to some of the television broadcasters who are up there, and they're working on some interesting digital plans. And it's been really fun looking at the RF side of things and the antenna design and how they're working it so that the RF on the ground is as most as you can get, so that you could entertain portable, as you pointed out, or mobile operation. But more so, I think portable here in New York City, especially, where they're looking to see if they can capture an audience on the street, if you will, or in office space and stuff on there, eventually on a portable device. Maybe it's the phone with an adapter. Who knows?
Building penetration is going to always be an issue in the city. In the concrete jungle, it was a problem back in the analog days, and I still think in ATSC3, although it's going to be more robust, I still think you're going to have signal issues inside some of those buildings.
Yeah, they did some measurements, and I have to say, from what I've seen, I can't give you details, but what I've seen, it's actually more impressive with the new antenna designs and how they're doing it, and then combination of the new modulation schemes. It may be a potential for something in the past we couldn't get, now we can.
Yes, I saw our SBE chapter here in Florida ran the video of John Lyons at the AES meeting last year, yes, where they did the tour up there in the top of the World Trade. It was pretty interesting.
Yep, that's the site I'm talking about. I was part of that video project, yeah.
Great.
Good deal. Chris, I know you've got to go, buddy. I appreciate you hanging around as long as you did. Thank you very much.
Yeah, I appreciate it, guys. And Hal, we'll catch up with you later, and Kirk, I'll catch up with you too.
Good luck with your broadcast. Hal and I will be here for just a few more minutes. Hal has a very interesting tip of the week, and I've got a little tip of the week too, a little turn of events. I often don't have one, but I do have one for you this week. You're going to want to see mine and hear Hal's, so hang on tight. Our show, This Week in Radio Tech, is brought to you in part by our friends at Lavo. Roll it.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks a lot to Lavo for sponsoring This Week in Radio Tech. And hey, please patronize all of our sponsors. Check them all out. All right, we are finishing up with Hal Kneller. And Hal, I'm going to go first here because my tip is quick and pointless. So here's a product. At the end of the show, we hope you to the last commercial to tell you about a tip that you might want to put to use in the coming week. And I have found an awesome tip. You know, with a lot of electronic equipment, sometimes it smokes, right? And when the smoke comes out, especially like a wiring harness, and a lot of equipment does still have wiring harnesses, you want to be able to put that smoke back in. And so here's the thing you need. It's from Lucas. This is made in England. It's replacement wire harness smoke. Now, this one is for positive earth only, as you can see on the label there, positive earth only. So I think the negative earth version is pretty rare. And I've still got to see if we can find that, but you may want to order some of this. Some people order it by the case, replacement wire harness smoke. So if you let the smoke out of your wiring harness, Here's how you put it back in with the product from Lucas, and that is my tip of the week.
Can you use it
Al,
on burnt resistors?
That would be awesome. Resistor. I haven't seen that yet. I got to see if I can find some of that. There's a business opportunity there, I think.
Yeah.
Yours is much more valuable, I believe. Al, what's your tip of the week?
Okay. So a few years ago, we bought an AM station here in Florida. It one time had an FM antenna on the top of the AM tower. And the line was there because the folks had taken the FM antenna down and put up a 950 STL antenna. But it had been abandoned for years, and we decided we were going to use it. Unfortunately, the line, which ran from the building out to the tower, about 150 feet to the tower, was buried underground, full of water.
What?
So I thought, well, maybe we can get some nitrogen and purge it out. And I hooked it up, and all it did was burble and bubble. A friend of mine suggested that we needed to really blow it out hard. So he suggested that we take an acetylene regulator instead of the nitrogen regulator, and we got some fittings and adapted it. And we put about 300 PSI into the input of this transmission line in the studio side of the building and disconnected the line at the base of the tower. And it went off like a fire hose. That water just shot out 20, 30 feet. And 2 or 3 tanks of nitrogen later, we had the line dried out, put all back together, and we had a nice STL transmitter going.
Okay, now, so you didn't actually put acetylene in here. You just used an acetylene regulator.
Right, because we needed the pressure. We couldn't get enough pressure. What, 30 PSI maybe out of the nitrogen regulator is all we could get. So we needed a couple of hundred PSI.
Okay, so I didn't realize that acetylene regulators were gauged so high. But
yeah, we could get a lot of pressure.
Okay. Wow. Now, did you? Was there some way that you held it back and let it go all at once, or did you just crank it up and see what happened?
A friend of mine who was another engineer stood outside at the base of the tower holding it, and we had our cell phones. We're talking, and he says, "Okay, I'm ready. Turn it on." And I turned it on. He says, "More." Turned it on. More. Kept saying more, more. Finally, I got it up to about 300 pounds, and it just started shooting out like a fire hose. And you needed to kind of do it that way, because if you got half the water out and then the other half was just sort of settled in the bottom of the line, it was going to be really hard to get out. This way, it just went out like a column of water.
Okay, so it went out as a column. Okay, so wow.
And then we kept running nitrogen through it for a couple of days. We ran several tanks through, and we were now running it through slowly, hoping to evaporate whatever moisture was left in the line. Put the ends back on, and that was it. Works fine to this day.
So just to be clear, this line was underground, and that's why it
buried
collected
underground.
All this water. Yeah, and you had no way
1
to get to it
air
otherwise.
dielectric heliax.
Yeah. Wow. I mean, you could have pulled it all out from underground. That would have been a big chore and probably not even worth it. Might as well bought some new heliax at that point.
It was called an AM station with a ground system.
Oh yeah.
Yeah, you wouldn't want to dig that up.
Oh my goodness. Hey, will I see you at NAB?
You will. We're doing a paper on SFN. Rich Redmond from Gates Air and myself.
Oh, good. Okay. Well, I'm doing a paper there too, but I hope I get time to see yours. You and Rich both. That'd be awesome. Hal, thank you so much for being our guest. Oh, and I wanted to let you mention you are working the company called Geo Broadcast. Is that it? Geo Broadcast Service?
Right. Geo Broadcast Solutions. And they do the SFN work for a lot of radio stations now. We're working in some big markets with it, improving signals all over the place.
Is there a website folks could go to, and I'll put it in the show notes?
geobroadcastsolutions.com.
Okay, that's kind of long, but I can type it all in, geobroadcastsolutions.com. All right.
And I still do contract work for the 2 stations I used to own, the 2 FMs here in Florida, so I stay in touch with those.
Good deal. Yeah, I still do a little engineering myself too, so try to eat my own dog food with the Telos gear.
Well, thanks for having me.
Hey, thank you for being on. Hal Kneller has been our guest, and all the stuff will be in the show notes. And tell your friends about This Week in Radio Tech. Coming up in the next week or so on the show, I want to give you a little clue as to who's on. Let's see here. Next week, Doug Irwin, the editor of Radio Magazine, is going to be our guest. He's got several things to fill us in on, so that'll be cool. On March the 1st, Nick Straka is going to be our guest. He's a frequent contributor at various online forums about engineering, so that's pretty cool. And then we've got Rob Hopkins with an interesting group called Open Broadcaster. It's open source broadcast software that you can run yourself or run in the cloud. So that's coming up a few weeks from now on March 22nd with Rob Hopkins. He's a Canadian. He's from way up north. All right, so we'll look forward to that. Thanks to Chris Tobin and Hal Kneller for being with us. Thanks to Suncast, the producer of our show. Really appreciate his efforts every single week. And thanks to Andrew Zarian, the founder of the GFQ Network. Tell your friends about us and subscribe if you would. On YouTube would be a great place. Just go to find This Week in Radio Tech on YouTube and click the subscribe button, or wherever your favorite podcasts are aggregated. We'll see you next week on This Week in Radio Tech. Bye-bye.